Alright, what we have here is a graduated cylinder of cold water. We have graduated cylinder of hot water. And what we are going to do is put some food coloring into each of the graduated cylinders. The food coloring is the same temperature, we just have hot water and cold water. So what we see is the cold water, the food coloring pieces are staying fairly compacted together and just dropping through the tube, whereas the hot water and the red food coloring pieces are being spread out throughout the warm water. Our question is why? Why does the hot water cause the food coloring to spread out more evenly, where the cold water just allows the food coloring to drop? And to do this, we need to look at the particle size, or the particles that are involved here. So we have hot water and we have cold water. And the hot water pieces, because they have more energy from the heat, are moving around much, much faster. And as they move around, they collide with each other, with the walls of the container, and also with the red food coloring. By colliding with the red food coloring, they send it scattering, also giving it some energy. So the red gets to spread out because it is being bombarded by the hot particle pieces traveling quickly. On the cold side, the cold food coloring drops straight to the bottom because it is slightly more dense than the water, so it wants to sink and sit at the bottom, but it doesn't really spread out throughout the whole water solution because the cold water pieces are moving slower and not really bumping into it as quickly. So you see some spreading out, but not nearly the amount of spreading that you would in the warm water.